So let's discuss about swap instruction. So swap instruction is somewhat similar to test and set instruction. In test and set instruction, in order to break the while loop, test and set instruction function, it used to return the old value of the lock, that is false, so that the while loop used to get broken. And after that, a new value of lock that is true is used to set, so that the other process will not enter the critical section if one process is already inside the critical section. So that was about test and set instruction. Swap instruction is similar to test and set instruction, except there is one thing. Here we will use swap concept that you might have heard in C programming. Okay, so similar swap concept we will use here. So let's see how. You see here I have written the code of swap instruction. So this part is function definition of swap. Okay, this is function definition of swap, and this part here, it will start from here. Okay, here you see swap function is being called here, and swap function is defined here. Don't worry, I will explain you one by one all these things. So I think I should give the line number. I don't know whether it's required or not, but let's give line number 1, 2, 3, 4, then 5, 6, 7, 8, 9, 10, 11. Okay. So you see here it's written. So from here I will start. Okay. Here it's written while one key is equal to true. So forget about this while, it's nothing. Key is equal to true. So here a new variable key is used. But in test and set instruction, we used lock. Here we will also use the key. So both lock and key will be initialized as false. Okay. So here I will write two variables are there. This one is key and this one is lock. Okay. So both are initialized as false. Now suppose two processes want to enter inside the critical section. You see here is the critical section CS. So two processes want to enter inside the critical section. Initially both these processes, process P1 and P2 are here. Okay. Suppose P1 has the CPU and P1 will enter the critical section. So how it will enter, you see. P1 will execute line number 5. Is it visible? I think yes. After that P1 will execute line number 6, and you see what's written in line number 6. Key is equal to true. So what will happen here? Here P1 will set the value of key as true. So here the value of key will be set as true. And also moreover one thing is that let's give the address of the variable 100 and 200. Okay. So now the value of key is true. After that you see a while loop is there. While key, while true. While true means what? Process P1 will enter inside the while loop. So while true. Okay. So after that from here while loop will start. So this while loop is from here to here. Okay. So here I will write, I am writing the braces. Okay. So this is the statement of this while loop. Okay. So while true, okay, while true correct. So now process P1 will enter here. So here you see what's written. Swap %lock, %key. So here you see a swap function is being called here. Inside the while loop, a swap function is being called here. And when the swap function is called, when the value of key is true. Okay. So I am repeating again. Process P1 will execute this line, key is equal to true. So the key value became true. After that, in a while loop, a condition is checked. While key, it means what? While true. If there would have been false, then P1 couldn't enter inside the while loop. Okay. So here is true. While true. Yes. So now P1 is inside the while loop, and inside the while loop you see swap instruction is being called. Swap &lock &key. So the address of lock and key is passed as a parameter. What is the address of lock? 200, and address of key is 100. So here you see a swap function is defined. From line number 1 to line number 4, swap function is defined. Fine. And here you see what I have written, void swap. It means what? This function will not return anything. It will just simply swap the value. It will not return anything. So let's see how. So you see &lock, swap &lock, &key. &lock means what? Here the pointer A will point to the address of the lock. So here pointer A will point to the lock variable, and here it's written boolean. Why boolean? Because the variable is holding true or false value, that's why. And &key, and here I have written boolean &b. So pointer B will point the address of the variable key. Okay, fine. So here you see it's simply a swap code, as you might have learned in C. Don't worry, I will explain here. Here you see what is written. Boolean temp is equal to star of A. So temp is a variable, fine, and it will contain star of A. Star of A means what? Value at the address pointed by A. So what is the address pointed by A? 200. And what is the value at 200 is false. So now temp is equal to false. Fine. And next line you see star A is equal to star B. Star A is equal to star B means what? Here A will contain the value of B. What is the value of A? I mean what is the value at the address pointed by A is false, and what is the value at the address pointed by B is true. So A will contain the value of B. So A will contain this true. So now the lock has become true. Fine. And after that, star B is equal to temp. So star B will contain the value of temp, that is false. So here the value of key will become ultimately as false. Fine. So now you see that the value of key and lock has been swapped. Initially it was true, false. Now it is false and true. Okay. So now you see how this swapping will help in the mutual exclusion. Let's see. Now you see, after the execution of this swap instruction, okay, after the execution of this swap instruction, the value of lock and key has been swapped. Initially, key was true and lock was false, and now key is false and lock is true. Okay. So after this, since it's a while loop, so while loop will run till the condition is true. If the condition is false, then while loop will not run. So okay, that's fine. So now P1 has executed line number 8. So now again it will come at line number 7, that is while, to check the condition. Okay. It will keep on checking unless there is a false, or you can say that let me write here. Okay. If the value of key is false, then only this loop will be broken. Okay. So now P1 will again come here and the condition will be checked while key is equal to true. So let's see. No, key is equal to false this time. So this time key is equal to false. So this while loop this while loop this while loop will be broken. Okay. And now P1 will enter into the critical section. Okay. Because now the value of key is false. False is equal to true. It's a false statement. So while loop will not execute. So line number 7 and line number 8 will not execute. So ultimately P1 will enter into the critical section. Fine. Okay. So up to here it's clear. So now you see, now we have to check whether there is a mutual exclusion or not. Okay. So you see here, P1 has entered inside the critical section. So let's try to enter P2 inside the critical section. Is it possible or not? Let's see. So now, suppose CPU is given to P2 and now P2 will run. P2 will execute line number 5. Fine. P2 will execute line number 6. And you see what's written in line number 6, key is equal to true. Okay. So here P2 has set the value of key as true. So here I will write key is equal to true. Fine. And after that P2 will enter in the while loop. At first the condition will be checked. While key is equal to true. Is key is equal to true? The value of key is true? Yes, true is equal to true. Fine. So now P2 will enter inside the while loop. So P2 will now execute line number 8. Okay. What's in the line number 8? Swap function has been called here. Okay. So here is the swap function. And you see %log comma %key. So here log and key's address have been passed as a parameter, and there are two pointers I've already explained you. A is pointing to log and B is pointing to key. And here there is a swap code written. Okay. So now you see. Boolean temp is equal to star of A. Temp is equal to star of A. What's there in the star of A? True. So here I will write true. Fine. In the next line, it's star of A is equal to star of B. Star of A is equal to star of B. Yes. I mean the value of B will be assigned to A. And yes, it's already true. Okay. And now star of B is equal to temp. Now star of B will contain temp. So it's already true is there. Okay. So here you see nothing has happened. As both lock and key are already true, and if both are true, then what you will swap? If there would have been true and false, then the value can be swapped as false and true. But here is true and true, then what you can swap? Nothing. So here you see the value of key remains true. Okay. So again, after executing line number 8, again P2 will execute this because it's a while loop and it will keep on executing until this condition becomes false. So here true is equal to true, condition is true. Again P2 will call this swap function. There will again it will be true and true, nothing will happen, the key will remain as true. Okay, so this will keep on happening because the value of key will remain as true. True is equal to true. So now you see P2 has stuck in this while loop, that is in line number 7 and 8. P2 has been stuck here. It means what? P2 can't enter inside the critical section because P2 has stuck in this while loop, line number 7 and 8. Fine. So, how can P2 enter inside the critical section? If P1, after execution of the codes of the critical section, if P1 will execute this line number 10, that is lock is equal to false, then only P2 can enter. So, till now you see mutual exclusion is there. So, will it continue? Let's see. Now, suppose P1 has completed its task while P2 is stuck inside the while loop. P1 has completed its task and P1 wants to come out of the critical section. So, for that P1 will execute this line number 10. Okay. So, now P1 will execute this line number 10. What's written in the line number 10? Lock is equal to false. So, P1 has made the value of lock as false. So, here it is false. Fine. And after that, P1 comes out of the critical section. That's a remainder section. Okay. So, now P1 is here. I mean to say that P1 has come out from the critical section. So, now you see, before coming out from the critical section, P1 has made the value of log as false. So, this statement will lead to the entry of P2 to enter inside the critical section, or you can say that this statement lock is equal to false will lead to the breaking of this while loop. How you see? P2 has got stuck inside the while loop. So again P2 will check the condition while key is equal to true. True, yes. So again P2 will call this swap function. Now you see the value of lock is false and the value of key is true. So value of lock is false and the value of key is true. So here you see when the swap function is called, so here is the swap definition. What this swap definition will do? This definition will swap the value of lock and key. So it is true and false. So this definition will make it as false and true. So let's see how. So now you see, yes. So A will point to the address of the lock. A is pointing to the address of the lock, and B is pointing to the address of the key. B is pointing to the address of the key. Fine. Now you see Boolean temp is equal to star of A. So temp is equal to star of A. What is star of A? False. Star of A is equal to star of B. Star of A is equal to star of B. What is star of B? True. So now star of A is true. And star of B is equal to temp. Star of B is equal to temp. Now star of B will contain this temp value, that is false. So now you can see the value of lock is false. So now when P2 will check this condition while key is equal to true, so this condition is false because now the value of key is false and false is equal to true is a false statement. How can false is equal to true be correct? So this while loop will be broken. Okay, this while loop will be broken and consequently P2 will enter inside the critical section. Fine. So it's very simple. If you know the swapping code, if you have learnt in the C, then this concept is nothing for you. It's very simple concept. Okay. And moreover, I have tried to explain each and everything. So I hope you got it. So some important theoretical points are there, like test and set instruction. This swap instruction, it supports mutual exclusion, you already know, and also it supports progress. Okay, but there is no bounded waiting at all. Fine. You just check it as I have explained you in the test and set instruction. There was no bounded waiting in the test and set instruction. So same thing will be there. Same thing will be here also. There will be no bounded waiting. Okay, because it is possible that suppose it is possible that suppose if P1 was there inside the P2 was there inside the while loop, it means what? P2 was waiting for P1 to come out of the critical section. After that, P2 will enter inside the critical section. Okay. But when P1 came out from the critical section, and before P2 could enter inside the critical section, P1 again entered inside the critical section. Okay, so this is possible. So there is no bounded waiting at all. That's a disadvantage. Okay, fine. So that was all about swap instruction. Thank you.